In this question, we learned that the local council is planning to construct a new sports ground in the shape of a rectangle with semicircular ends. A running track, 400 meters long, is to go around the perimeter. So we'll have a 400-meter perimeter, we have a rectangle, and two semicircle ends. From each of the rows on the right, choose the statement that best completes the sequence of statements leading to the equation to determine the maximum area of the rectangle. The first thing that we need to do in order to come up with a function to determine the maximum area of the rectangle is to begin by finding a function for the perimeter. The perimeter in this case is equal to 2x plus 2 pi r. The 2x represents the length on the top and the length on the bottom, and the 2 pi r represents the circumference of a circle. We have half a circle on the left and half a circle on the right. In addition, we know that the perimeter is equal to 400, so that can be substituted in for p. From here, we need to isolate for our variable x. In order to do so, we'll take the 2 pi r and we'll subtract from both sides of the equation. When we do so, we have 2x is equal to 400 minus 2 pi r. From here, in order to get x by itself, we will divide both sides by 2, and we have the following. The next thing we need to do is come up with a function for the area. The area is equal to 2xr. The x represents the length across the top, and notice that we have r as a radius, which would make 2r as the entire width. So 2xr is our area. Next, we'll take our function that we have up here, x is equal to 200 minus pi r, and that'll be substituted in for this x. When we do so, we have 2r all multiplied by 200 minus pi r. Notice that this has just been substituted in for the x. Distributing out the 2r gives us 400r minus 2 pi r squared. In descending order of powers, we have negative 2 pi r squared plus 400r. And now from here, we're ready to go ahead and complete our square. When we complete our square, we have to factor out a negative 2 pi because that is our leading coefficient. When we factor out negative 2 pi, we're left with the following. Negative 2 pi has come outside, and then inside now we have r squared minus 200 r all over pi. Notice that the 400 has been divided by negative 2, and we've also divided it by pi. From here, we will take negative 200 over pi, we will divide it in half, and then square it to generate these two terms. The negative 10,000 over pi squared will get multiplied by our leading coefficient to move it outside of the brackets, which gives us 20,000 all over pi. And then finally, we're ready to go and complete the square here. We'll take r squared minus 200r over pi plus 10,000 over pi squared, which gives us the following. Negative 2 pi all multiplied by r minus 100 over pi squared plus 20,000 all over pi. So, we've determined the function that will maximize the area of our rectangle. Finally, let's check our solutions, and we are correct.